Myself Patel, working as assistant professor in IT/ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the next topic as a permutations. Now in permutation, here we discuss the first what is the permutation. Here permutation means we can say the possibilities of your sequence, possibilities or arrangement of the objects. So here continuing to examine application of the rule of product, we turn now counting linear arrangement of object. So permutation is a simply linear arrangement of object. These arrangements are often called the permutations when the object are distinct. So for the distinct object, we have to arrange the object in some way, in some sequence, in a linear order. It is called the permutation. The permutation of a set S of objects is an order arrangement of the elements of S where each element appears only once. So for example, here 3 elements are available, 1, 2 and 3. Then what is the different possibilities? What is the different sequence are possible from this order? So here 1 is 1, 2, 3, then 2, 1, 3, then 3, 1, 2. So these all are considered as a permutation, linear arrangement of objects. Now see here, an order arrangement of R distinct elements of S is called the R permutation. So n element are available, so R permutation is also possible for that, for given n element. So from the given n element we have to select only R element, then it is called the R permutation. The number of R permutations of a set S with n equal to mod S. So S having n element, from the n element we have to select only R element, then it is called the PNR permutation for n R element. It is equal to n minus 1 up to the n minus R plus 1. It is called the n factorial divided by n minus R factorial. Now see here, example of the permutation. In a class of 10 students, 5 are to be chosen and seated in a row for a picture. How many such linear arrangement are possible? So in a class total 10 students, we have to arrange 5. The keyword here is arrangement, which define the arrangement as a linear arrangement. So see here, A, B, C, D, E, F, G, H, I and J. This is considered as a 10 students. Name of this 10 student considered as a to J. Now here for example we have to select only 5 students from this 10 student. Then how many possibilities are there? So for that, for example, we can say that the first possibility as a B, C, E, F, I. Each and every student is a different student. All the 5 students are different students. Second, C, E, F, I, B. And third, for example, A, B, C, F, G. Are the 3 such different arrangement even though the first 2 involves the same 5 students. So here, for this 5 student, if we select the same 5 student, then also many possibilities are there. And when we use the different student from this 10 student, then so many possibilities are. Now for that, here to answer these questions, we consider the positions and possible number of students we can choose for this particular position. So for that, here see that total 10 students are available. We have a total 5 possibilities, 5 positions. So for the first position, how many students are possible? So for the first position, we consider the A, B up to J. That means total 10 possibilities are there for the first position. Now for the second position, here repetition is not allowed. That means 9 possibilities for the second position. Now for the third position, 8 possibilities. Now for the fourth position, 7 possibilities. And for the fifth position, 6 possibilities are there. That means from the available 10 student, if we want to select the 5 student, then answer is multiplication of this all. 10 multiply 9 multiply 8 multiply 7 with multiply 6. So each of 10 student can occupy the first position in the row, because here no any selection is done before that. So first row having 10 possibility, second row having 9, 8 like this. Now final answer for this multiplication is 30240. That means these are the possibilities or possible arrangement of 5 students selected from the available 10 students class. So this is our answer for that. Now for this permutation, first we understand the what is factorial, because we have to relate this thing factorial with the permutation. So for the factorial, for example, for an integer n greater or equal to 0, n factorial denoted by the n factorial is defined by 0 factorial, that means 1. Now n factorial means n into n minus 1 into n minus 2 into n minus 3 up to the 3 to 1 for n greater or equal to 1. Now for example, we can say that 1 factorial equal to 1, 2 factorial equal to 2, 3 factorial equal to 6 means 3 cross 2 cross 1. 4 factorial means 4 cross 3 cross 2 cross 1 equal to 24. And 5 factorial equal to 120. Now here we can say that the common formula for the factorial is n into n minus 1 into n minus 2 up to the 1. In addition, for each n greater or equal to 0, n plus 1 factorial equal to n plus 1 into n factorial, because n factorial equal to n minus 1 n minus 2 like this, but n plus 1 factorial, that means n plus 1 into n factorial. Now using this rule we can apply in this our previous example. So here we have a sequence is like 10 into 9 into 8 into 7 into 6. Now here we represent this sequence in another way, is like 10 into 9 into 8 into 7 into 6. This is a given sequence, but for considering the 10 factorial, what is the remaining thing? Remaining thing is 5 into 4 into 3 into 2 into 1. So multiply this thing and divide this thing. That means nothing is changed in previous sequence. So here we divide and multiply with 5 cross 4 cross 3 cross 2 cross 1. So upper side is considered as a 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. That means 10 factorial. Divide by 5 into 4 into 3 into 2 into 1. Now what is the meaning of 5 cross 4 cross 3 cross 2 cross 1? 5 factorial. That means 10 factorial divided by 5 factorial is the answer for our previous example. This is another way for representing this equation. Now, given a collection of n distinct objects, any arrangement of this object is called the permutation of the collections. So for that, starting with the letter A, B, C, there are the 6 ways to arrange or permutate this all the letters. For example, first is A, B, C. Second is ACB, then BAC, then BCA, next one is CAB, and last one is CBA. Total 6 possibilities are there for arranging this letter in different sequence. Now for that, here we consider 3 letter available and we have to use the 3 letter for arrangement. Then this is a NN representation. Now here given 3 characters are available A, B and C. And you have to arrange only size of 2. That means you have to consider subset of 2 elements. If we are interested in arranging only 2 of the letters at a time, there are 6 such size 2 permutations like AB, BA, AC, CA, BC and CB. So this is called the NR arrangement. Now for the common equation for that. If there are n distinct objects and R is an integer with 1 less or equal to R less or equal to n, then by the rule of product, the number of permutations of size R of the n object is, we can represent like P of nr equal to n into n minus 1 into n minus 2 up to n minus R plus 1. So this is a common formula for find the permutation for P and R. N means available objects and R means selected objects. So here formula is like this: P and R equal to n into n minus 1 into n minus 2 up to the n minus R plus 1. So n means first position, n minus 1 means second position. For example, 10 into 9, that means 10 is a first position, 9 is a n minus 1 as a second position, up to the rth position value as a n minus R plus 1. So in our previous example, we write 10 into 9 into 8 into 7 into 6. Then 6 means 10 minus 5 plus 1. It is called the 6. So for that we can write the common equation like this. So n into n minus 1 into n minus 2 up to the n minus r plus 1. Now multiply next position as a n minus r, because previous one as a n minus r plus 1, then next one as a n minus r, then next one as a n minus r minus 1 up to the 3 2 1. So multiply and divide this same thing with the previous equation, and we will get upper side as a n minus 1 up to the 1, that means n factorial, divide by lower side, consider the n minus r minus 1 up to the 1, that means the n minus r factorial. So common formula for the p of nr equal to n factorial divided by n minus r factorial. Now see here, p of nr equal to n minus 1 up to the n minus r plus 1, that means n factorial divided by n minus r factorial. Now for the value of r equal to 0, that means we have a n number of element available, a b c d up to n, and we have to select only 0 element from this, that means p of n0, r equal to 0. So how many possibilities are there? So here only empty set is possible, that means possibility is equal to 1. So according to our formula, n factorial divided by n minus r factorial, so n factorial divided by n minus 0 factorial, so n divided by n factorial divided by n factorial, that means 1. So answer of this equation is 1. Now consider the another scenario as a r equal to n, that means we have a n element and you have to select the n element from available n element. So r equal to n. Then equation is p of nn equal to n factorial divided by n minus n factorial, that means 0 factorial. So n factorial divided by 1, that means n factorial. So answer equal to n factorial. A special case of this result in previous example is like n equal to 10, r equal to 5, that means we have to find p of 10 5 and is equal to 30240 according to our this equation. Now here, however, if representation or repetitions are allowed in this sequence, if we permit the repetition of the any number or any character, then how many possibilities are there? So for their arrangement possible for this sequence is n raised to r possible arrangement with r greater or equal to 0. So here if we want to repeat the element, then n raised to r possibilities are there. Now for that, understand using this example. How many ways are there to pick a set of 3 peoples from the group of 6? So n equal to 6, we have a total 6 person. Out of the 6 person, you have to select only 3 person. That means according to our formula, we can say that the 6 cross 5 cross 4 equal to 120. So here we can say that the n equal to 6, r equal to 3. So 6 minus 3 plus 1 like this. So last element as a 4. Now after that, understand this second example, the computer or the number of permutations for the later word computer. So for the computer word, you have to find the how many permutation is possible. So for that, understand using this example. So here we can say that the 8 factorial is our answer. So for example here, we can say that if only 5 of the letters are used, then number of permutation is P85. If we use all the element, then 8 factorial, because according to our formula, P of nn equal to n factorial. So if you want to use the different 8 character COMPUTER, then possibility is equal to n factorial, that means 8 factorial. But here if you want to find the set of characters as a only 5 character from the available 8 character, so it is called the P of 85. That means 8 factorial divided by 8 minus 5 factorial. So 8 factorial divided by 3 factorial and answer equal to 6720. So using this formula, we can find the answer like this. If repetition of letter is allowed in this example, then how many possibilities are there? If you want to find the 12 letters sequence, 12 letter combination, then here repetition is allowed. Then according to our equation is n raised to r. That means 8 raised to 12 equal to 6.872 multiply 10 raised to 2. So here our answer is like this. Now next example is the number of linear arrangement of the 4 letter BALL. Then how many possibilities are there? So here, remember that in computer no any repetition are possible, but here L is repeated 2 times. That means according to our previous formula, we can say that the 4 factorial, but here answer is not as a 4 factorial, not equal to 24, but answer is only 12. Why? Because here see in this table, if we arrange this letter L 2 times, then if L is the same, then only 12 possibilities are there according to first part A of this figure. But if we consider the 2L as a L1 and L2, then both L are different. In this case, we find the different 24 possibilities according to second figure B. So here no any specification are given for the 2L, L1 and L2, so we can use the both the L are equal. That means total 12 possibilities are there for this. Here we can say that the symbol as a B, A, L1, L2, then 24 possibilities are there. Now for that we can use the common formula for this is like this, 2 into, because here 2L are repeated, that means we multiply 2 into number of arrangement of the letter BALL equal to number of permutations of the symbol BAL1, L2, both are equal. Now for that, here we can say that the final answer for the ball is equal to 4 factorial divided by 2 equal to 12. So 12 arrangement are possible for this example. Now next example is the arrangement of all 9 letters in databases. So here a character is DATABASES. Now see here, A is repeated 3 times, S is repeated 2 times. So here 3 factorial is equal to 6 arrangement with the A's different value. So here we consider the different value of A as a A1, A2, A3 like this. So arrangement is like this, for example D, A1, T, A2, B, A3, S, E, S. Second, first we use the A1, then A3, then A2. So these all are the different arrangement for the A1, A2 and A3. Now second thing, here A is repeated 3 times and S is repeated 2 times. So if we use the S as a 2 time as a different name S1 and S2, then arrangement is like D, A1, T, A2, B, A3, S1, E, S2. Then if we change the sequence of S1 and S2, then second sequence is first S2, then S1. So for the different value of S. Now for that, how many total permutation are possible for the sequence database? So here we can say that the 3 repetition of character A as a 3 time, that means 3 factorial. Repetition of the character S 2 time, that means the 2 factorial. So our final equation is 2 factorial into 3 factorial into number of arrangement of the letters in databases is equal to number of permutations of the symbols D, A1, T, A2, B, A3, S1, E, S3. That means we can say that the 9 factorial divided by 2 factorial into 3 factorial. Here 9 factorial, that means different 9 characters are available. That means for using repetition you can use the 9 factorial values, n factorial values divided by repeated element, that means 2 factorial and 3 factorial. So final answer is 30240. Now common formula for this is, if there are n objects with n1 distinct elements or objects of a first type, n2 distinct object as a second type, so here repeated element considered as a n1, n2, n3 up to nr. That means n1 as a indistinguished element, that means repeated element for first object. N2, that means repeated element, indistinguished element of the second object. And nr is a repeated element of the rth object. So for the n1 plus n2 up to the nr equal to total n. Then there are following arrangement are given. So common formula is n factorial divided by n1 factorial, n2 factorial up to the nr factorial. Here consider first upper side as a n factorial and lower side as a n1 factorial, n2 factorial up to the nr factorial. So here this is a common formula for finding the permutation for the given sequence. So here in this example we can say that the, for example consider the different character as a M, A, S, S, A, S, A, U, G, A. Then how many different possibilities are there? How many arrangement are possible for this sequence? So here total 10 character are available. So upper side we can write the n factorial, that means 10 factorial. Now divide by how many repetition are possible here? So A repeated 4 times, that means 4 factorial. Now S repeated 3 times, that means 3 factorial. Then M used for 1 time, so 1 factorial. Then U used for 1 time, so 1 factorial. And G used for 1 time, that means 1 factorial. So 10 factorial divided by 4 factorial into 3 factorial into 1 factorial into 1 factorial into 1 factorial, that means 25200. So this is a simple example of the permutations. Now another example of the permutation is, for example, in a graph you have to move from the location 21274. Now here scenario is you have to transfer or move according to upper side or right side, upward or right. Upward represented by U, right represented by R. So see here, here our arrangement in first figure is like first right, then U, then R, R, then U, then R, then R, then U. In second arrangement our sequence is like first U, then R, 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 then U, U, then R, R. So these two are the different sequence. So how many different type of sequence are possible for this example? So for that we have to find the value of U and R. So how many times R repeated? R repeated 5 times. U repeated 3 times. That means our movement is 7 minus 2 equal to 5 horizontal movement, and right movement is like 4 minus 1 equal to 3. That means 3 vertical movements. Now here see that the total movement is 8, because here combination of R and U total equal to 8. That means upper side we have to write the 8 factorial. Now how many time particular character is repeated? So R repeated 5 times, U repeated 3 times. That means 8 factorial divided by 5 factorial into 3 factorial is equal to 56. That means total 56 arrangement are possible. Different 56 way are possible from moving the location 1 to location 4, 7, like this. So here we can use this scenario as a moving from 2, 1 to 7 for different 56 possibilities. So in this lecture we discuss about the permutation and how we can find the permutation for given data. Thank you for watching this video.